The universe is a story told across eons, and entropy is its narrator, soft-spoken, patient, unrelenting. We often speak of endings in terms of drama, fiery destruction, violent collapse, cataclysm, but entropy imagines a different finale, not a bang, but a fade. In the beginning, the cosmos was ablaze with imbalance, hotter than stars, denser than black holes, raw potential everywhere. But over time, like steam escaping from a cooling kettle, that intensity has dissipated, flowing outward into structure, then into silence. We do not live in a universe at rest. We live in one still spilling its original heat, still tumbling toward thermodynamic equilibrium, a place where all gradients flatten, where nothing moves because nothing must. This is not peace. It is the absence of possibility. In the long view stretching beyond stars, beyond galaxies, entropy isn't just something that happens inside the universe. It shapes the very future of the universe. The day will come when there are no engines left to run, no warmth left to disperse, no boundary between hot and cold. That's what entropy wants. Not destruction, not chaos, just stillness. And the cosmos, for all its brilliance, is slowly preparing to oblige. We measure our nights by starlight, but the stars are not forever. Each one is a furnace, balancing on a razor's edge, gravity pulling inward, fusion pushing outward. It's a delicate agreement, but it's not eternal. Now, stars, like everything else, burn through their fuel. They are finite machines in an infinite sky. Some will end quietly, like our own sun, shedding their outer layers in graceful planetary nebulae, leaving behind white dwarfs no bigger than Earth, but unimaginably dense. These dwarfs will shine for trillions of years, then go dark, cold, crystallized, forgotten. Others will end in fury, massive stars collapsing in on themselves, detonating as supernova, seeding the galaxy with gold, iron, and oxygen. From these explosions, remnants remain. Neutron stars with the mass of suns crushed into the size of cities, or black holes so collapsed, so curved, that nothing, not even light, can escape. Each death writes a new chapter in entropy's journal, not because stars prefer to end, but because they are caught in the rules of thermodynamics. Every joule of light they give, every neutrino they release, is a debt to disorder. They shine, yes, but only by breaking down. And as the centuries pass, the starfields thin, the luminous age dims. Entropy does not extinguish stars. It lets them burn, then waits. If entropy is a tide that rises everywhere, then black holes are its greatest floodplains. They're not merely collapsed stars. They are boundaries in space-time, horizons beyond which information falls and does not return. Black holes, as strange as they are, seemed for decades to violate thermodynamics. They had mass, they had spin, but they had no temperature. How could they grow in entropy if they didn't even radiate? And then Hawking changed everything. In 1974, Stephen Hawking combined general relativity with quantum field theory, and he discovered something almost unthinkable. Black holes aren't perfectly black. They radiate. Not much, not quickly, but enough. This radiation, now known as Hawking radiation, means that black holes have a temperature, and if they have a temperature, they have entropy. In fact, a black hole's entropy is enormous. The entropy of a black hole exceeds that of any known object of similar mass, and yet it's measured not by what's inside, but by the surface of the event horizon. This shocked physicists. It suggested that the information content of a volume might live on a boundary, that space-time itself might be holographic, a projection from a surface into a space. Here, entropy becomes not just a measure of disorder, but a clue to something deeper, that the universe may be more informational than physical, that entropy isn't just counting heat, but meaning. But there's a deeper mystery. What happens to the information that falls into a black hole? Does it vanish? Does it stay encoded on the horizon? Does it escape in the slow whisper of Hawking radiation? This is the black hole information paradox, and it cuts to the core of physics. Because if entropy measures hidden information, and if black holes erase it, then perhaps entropy itself is incomplete. Or worse, our understanding of reality is. Some theories say information escapes subtly, encoded in radiation, Others say it's scrambled but preserved. Still others propose firewalls, violent boundaries that vaporize incoming matter. We do not yet know. But what we do know is this. Black holes are not the end of entropy. They are its monuments. Silent, hungry, almost eternal. And yet not quite. Because even black holes, entropy's darkest vessels, will one day fade. The future isn't fire, it's equilibrium. We imagine endings with explosions, with grand finales, with a bang. But entropy doesn't deal in spectacle. It deals in settling. The end of time, if it comes, will be cold. Not because something failed, but because everything finished. This is the idea of heat death, a state where all usable energy has been spread too thin to do anything at all. A state where every gradient has been erased, every light extinguished, every motion ceased. At that point, the universe will not be dead. It will be indifferent. Because even atoms need contrast to collide. Even information needs difference to be stored. Even thought needs warmth to flicker. In the era of heat death, the cosmos will remain vast and silent, filled with low-energy radiation, stretched thin by expansion, trapped in uniformity so complete that nothing can ever change again. No new stars, no new entropy, because there is nothing left to be lost. This is not destruction. It is the final equilibrium of everything that ever was. Though it sounds desolate, it is not cruel. Entropy has no intention, no judgment, no malice. It is simply the tendency of the possible. It's fulfilled completely. Still, before the final hush, there will be whispers. Long after the last star collapses, after galaxies have dissolved into dust and the cold has crept into every corner of space-time, a few monuments of gravity will remain. The black holes. These are not eternal. Thanks to the quantum dance of uncertainty, black holes slowly leak energy into the void, an effect known as Hawking radiation. This radiation is faint, almost imperceptible in the short scale of cosmic time. But in the eons ahead, it becomes the last performance in the universe. As a black hole loses mass, it gets smaller, and as it gets smaller, it gets hotter, and as it gets hotter, it radiates faster. This forms a slow crescendo. Billions of years of quiet, followed by a sudden final burst. A black hole's last breath. No light escapes, no sound accompanies it, just a fade, a silence, and then nothing. And so, the very entities once thought to devour the universe become the final source of its light. When the last black hole evaporates, the universe will not be empty. It will be featureless. All the structure that once danced between stars, planets, and people, dispersed into randomness too perfect to be noticed. The universe, once so full of purpose, will carry only presence, a canvas wiped clean. When there are no more processes, when there is no more information to lose, when no event distinguishes itself from any other entropy, will have reached its final destination. But that destination isn't oblivion, it's completion. Entropy is not the villain of physics. It's not the destroyer, it's the keeper of closure. Because the universe didn't begin in silence. It began in a roar of difference, hot and dense and filled with tension. It had to settle. And entropy was the law that wrote its arc from beginning to balance. We often ask what the point of it all was. Why stars were born, why life emerged, why we remember anything at all. But that question assumes there was a reason. Entropy offers a different kind of answer. Not a reason, but a path. Everything that ever happened was one step further down that slope. Not by accident, but by inevitability. And somehow, in that long decline, order formed. Patterns appeared, eyes opened. For a brief window of time, the universe became capable of knowing itself. And even if memory fades, even if structure dissolves, even if time itself becomes irrelevant, for a while it mattered, because meaning doesn't require permanence. It only requires emergence. So when we speak of the end of, the death of stars, and the flattening of all difference, we're not speaking of failure. We're speaking of fulfillment, of a law that was never broken, of a journey that was never paused. Entropy always wins. But in its wake, it gave us galaxies, music, minds, and love. Fleeting, yes, but exquisite. We do not fight entropy, we ride it. And in doing so, we leave behind the most unlikely of things: a trace.